Hello, this is a short video presentation on graphing quadratic equations without a graphing calculator. Quite frankly, this is much easier than what we've been doing. First of all, the equation needs to be in vertex form, as shown here. It needs to be in the vertex form in order to do this. All right, let's start graphing. The first thing you want to do, once you're in vertex form, is to make sure you know what the vertex is. Now, looking at this problem right here, x minus 2 means the vertex is at x equals 2. The minus 5 means it's at 2, negative 5. So we go here to 2, and down 1, 2, 3, 4, 5. That's my vertex. Now, think of having a line going through the vertex, and when x is 3, x equals 3, 3 minus 2 squared is 1 squared, or 1. That means I'm 1 above negative 5, or 1 above this line, so I put a dot there. When x is 4, 4 minus 2 squared is 4. That means I'm 4 above this line. 1, 2, 3, 4. And when x is 5, 5 minus 2 squared equals 9. I'm 9 above this line here. 1, 2, 3, 4, 5, 6, 7, 8, 9. And if I was one more over, 6 minus 2 is 4, that'd be 4 squared, or 16. So you see, this is 1, this is 4, and this distance here is 9. All right? And it continues that way. All right, let's just erase this stuff here. All right. Now, our axis of symmetry is along here. And then our graph goes on the other side. I'm 1 here, I'm 1 here, 2 over, 2 over, 3 over, 1, 2, 3 over. And my graph looks like this. Arrows always. Label our axis of symmetry, x equals 2, our vertex, 2, negative 5, and our y-intercept here, y-intercept, negative 1. All right, and we're done. That easy. All right, let's do another one. Y equals negative x plus 3 plus 6. Our vertex, negative 3, 6, negative 3, 1, 2, 3, 4, 5, 6. And we have an imaginary line here. When x is 1, 1 squared is 1. When x is 2 away from the vertex, in either direction, we have 2 squared is 4, 1, 2, 3, 4. With 3 away, 3 squared is 9, 1, 2, 3, 4, 5, 6, 7, 8, 9. Our axis of symmetry goes down here. 1 over, 2 over, 3 over, and now we have our parabola. Arrow, arrow, an ugly arrow, y-intercept, negative 3, vertex, negative 3 positive 6, axis of symmetry, x equals negative 3. And I forgot my squared on my original equation. All right, what happens when the coefficient is not 1? We'll do one more. Y equals 1/2 times x plus 1 quantity squared minus 4. Our vertex, -1, -4, 1, 2, 3, 4. And we go up because we're positive. Now, our little imaginary line there, if x is 1, I have 1 plus 1, I'm sorry, if x is 0, because we started here at -1, we go to 0. If x is 0, we get 1 squared times 1/2 is 1/2. I'm not going to mess with decimals. If x is positive 1, 1 plus 1 is 2, 2 squared is 4, but times 1/2 is 2. If x is 2, 2 plus 1 is 3, squared is 9, gives me a decimal. So then I'm going to go over 1, 2, 3, 4 squared, or 4 squares. So when x is 3, 3 plus 1 squared is 16, but its times 1/2 is 8. So 1, 2, 3, 4, I go up 1, 2, 3, 4, 5, 6, 7, 8. And continue like that. So instead of just going up 1, 4, 9, we go up 1 times 1/2 is 1/2, 4 times 1/2 is 2, 9 times 1/2 would be 4 1/2, and 16 times 1/2 is 8. But we don't have to mess with those halves. All right. Draw our axis of symmetry. And our graph. We're 2 over here. We're 2 over here. We're 4 over here. 1, 2, 3, 4 over here. And then we can draw our graph. Goes dun-dun-dun-dun-dun, with an arrow. Dun-dun-dun-dun-dun-dun, with our arrow. Our vertex is at -1, -4, -4. Our axis of symmetry, x equals -1. Now, where is our y-intercept? The y-intercept happens when x equals 0. So if I put 0 into my equation, 0 plus 1 squared minus 4, or 1/2 times 1 minus 4, or 1/2 minus 4. Common denominator, and we get 1/2 minus 8/2, or -7/2. All right? Or you could say -3/2 also, -3.5. So my y-intercept is -7/2. And we're done. All right. I hope this makes sense to you. Make sure on today's homework or the next assignment, you do not use your graphing calculator. All right. Thank you and have a great day.